Hey guys, we're back. Let's jump into vertex form in quadratic equations. Yesterday we were talking about standard form where we kind of had to make a chart to plot some points and figure out what's what. This is a form that a quadratic equation can be in that will literally give us the information of where the vertex is. It's amazing. So we know we've seen this before, but we have y equals a, which is a value which will remember a tells us if it's positive, it goes up. If it's negative, it goes down. Remember, we learned that last time. But now we see some other values. We see x minus h and a positive k out here. This tells us what our vertex is. Our vertex is the x value is whatever h is. Keep in mind, there's a negative in front of the h, so you always look at the opposite. And k is our y value of the vertex. We also know that the axis of symmetry, or AOS for short, is x equals whatever the h value is, okay? So looking at that, if this graph right here is y equals x squared, okay? If I were to change that by turning it into, I'm going to show you over here, this equation here where I adjusted it by h comma k. So this distance we'll say this distance is h. So I'm moving it over to the right h units, and I'm moving it up k units tall. So we're going to go over h up k units. Then it looks like the same shape, but we've shifted it over, where this vertex, instead of being at 0, 0, is h comma k. So we look for that here and here. So let's practice. So if we were to graph a different type of equation, let's look at how we would do this. So first of all, step 1, we're going to look at the parts of the form that we need. So we're going to look at the form. We're going to look at A. We're going to look at h, and we're going to look at k. So here's A. That's a positive 2. Since it's positive, I know this is going to be going upward. H, remember, it goes x minus h. So if I don't see a minus here, I'm going to break this up into a minus, a negative. So this is our h is negative 2. And k is after the plus sign is a positive 5. So the vertex, step 2, we're going to identify where the vertex is h comma k, negative 2, 5. And let's go ahead and plot the vertex as well as the axis of symmetry. So the vertex is negative 2 comma 1, 2, 3, 4, 5. There's my vertex. And we know the axis of symmetry is going to go straight through the vertex, and it's a vertical line. So we know the axis of symmetry is x equals whatever h is, which is negative 2. And then the last thing we want to do is make sure we have at least one other point so we can look at this. Here, we don't necessarily have the y-intercept from a value of c. So we're just going to plug in any value that isn't x equals negative 2, and we're going to find another point. So we're going to evaluate another point. You can choose what that wants to be. So because we have this one at negative 2, I'm going to pick when x is 0. So let's see what happens when x is 0. Y equals 2 times x plus 2 squared plus 5. So let's look at that. I know 0 plus 2 is 2. 2 squared is 4. And 2 times 4 is 8 plus 5 is 13. So then when x is 0, y is 13. So we're going to graph that here. So here's 5, 6, 7, 8, 9, 10, 11, 12, 13. So that's my point 0, comma 13, which is also on the parabola. So I know if this is my vertex, it's going to go up through here. And remember, since this is my axis of symmetry, it's going to be exactly the same on the other side. It's too bad that that's too wiggly. okay? All right, let's go to the next page. So what if it looks like this? This is what's called intercept form. This looks a lot like factors. Sometimes people call it factored form, but from this form, we know that we can find the x-intercepts. Remember that the x-intercepts are where the graph crosses the x-axis. So we know it's x-intercepts, and also we can tell that the axis of symmetry is in the center of the values p and q. So here's what that means. So let's say, for example, you have y equals 2x plus 3 and x minus 1. So looking at this form, the x-intercepts are the value of p and the value of q. So here's the deal. I have to see a times x minus p and x minus q. Well, here's the deal. There's no minus here, so I split that up to a minus and negative. And I'm going to look, so a equals 2, p equals, and again, p is here, so it's after the minus, that's a negative 3. And q is 1. So this is an x-intercept and an x-intercept. And we know 2 is going to go up. So I go at negative 3 on the x-axis and positive 1. And we also know that in the center of this is our axis of symmetry. So what's in the center of negative 3 and 1? So we can go over, basically that distance is 4. So we can go 2 in from the right and the left, and there's our axis of symmetry at x equals negative 1. Okay, and we know because a is 2, it's going to be going upwards. It's going to look something like this. Okay, so if I want to find the vertex, we know x would equal negative 1. You can plug that back into here. Y equals 2 times negative 1 plus 3 times negative 1 minus 1. And we get 2 times positive 2, negative 2, and we get negative 8. So this value here is at negative 8. All right. I'll see you back in class.